So when we left, we just started talking about how biodiversity might be related to ecosystem function. And a number of people made arguments when we were talking about whether more diverse systems are more stable, that you could have functional redundancy. And what that means is, let's say you have somebody that eats leaves and they fall into the stream, some organism. If you have a couple species that do it, then one can take over for the other. And so if there's disturbance, then there might be more complex systems, might be more stable essentially to disruption. You may remember when we talked about the chytrid fungus moving into Panama and the work that we did down there. And we went through an experiment where we had nitrogen-15 as a tracer and put it into the food web and looked at how things cycled. And the frogs, there were 20 species of frogs there, so tadpoles that use that stream. Some of them were quite big grazers and that kind of thing. They were completely wiped out, and then we went back in 2 years in between those two times because the fungus disease swept through their chytridomyces. There's a lot of algal growth. The nutrient uptake was not as high. There were a lot of functional changes in that system related to loss of the biodiversity. In that case, a student went back about 5 years later and looked at it, and the macroinvertebrates had not taken over for the frog, for the tadpoles. So there's another example where biodiversity might be related to ecosystem function. This has been a somewhat controversial topic in that it needs to, we want to preserve biodiversity for many reasons, but one of the arguments on biodiversity is that it controls ecosystem function. And so the ecosystem services that we rely upon might be harmed by that, by harming biodiversity. An example, an image people use to describe that is you're on an airplane, and if there's functional redundancy, that would be the same as all the rivets that are holding on the wings. And if you look out the window and you see a rivet pop off, it's going to make you nervous, but maybe it's like, oh, okay, but then another one pops, and eventually if enough rivets pop off, then wings going to fall off and everyone's going to die. So that's the kind of parallel example that is oftentimes given to that. This is inevitable that the biodiversity will decrease in freshwaters, and that the ecosystem will change, I think. And it's a bigger effect when it's on islands than when it's when you're on an island, freshwater systems and islands, than when you're in the mainland. And why do you think that is? First, start with island biogeography, and do we expect diversity to be higher or lower on an island than in the continental areas? Good. Yeah, on the island it would be lower. Okay, so if diversity is lower, that means taxonomic diversity, right? But could that be related to functional diversity? And the question being, if you lose functional diversity, right, nothing's going to make up for anything. So this is where we get back to the diverse systems being more stable. Right, so there's going to be less effective biodiversity decreases in areas that are more diverse. There's also some examples that we'll talk about very soon here on keystone species, or species that have a disproportionate influence on the ecosystem they're in. Be they ones that are there already and are extirpated from an area will have a large effect on ecosystem function, or those that are introduced or non-natives that get introduced and can also really change the character of ecosystem function. One of the questions is you know, what is ecosystem function and what's good ecosystem function as far as the service goes. When I ask this question, it's kind of embedded in there. And we talked about ecosystem services, but we can look at an example of primary production of a lake. Is it a good thing if primary production of a lake is really high? Is that a good outcome? Like hypertrophic system. Right, so function is really going, primary production is really going. Is that a positive or a negative thing as far as humans go? Yeah, it depends on the amount of production. So what I'm saying now is if it's super high, right? We're talking about a super eutrophic lake. Right, we do not like it. Good, man. Essentially, algal blooms, they'll drop diversity, right? They'll cause fish kills, harmful, all those kinds of things, right? But then if you look at the other side of things, if you look at some production is necessary. So if you're interested in having a good productive fishery, you're going to catch more fish, probably, and they'll be more productive in a mesotrophic lake than an oligotrophic lake. And we talked briefly about Waldo Lake, which is an ultra oligotrophic lake, and it's so nutrient poor that they stock trout in there repeatedly, and they're not able to get any reproduction because the fishes had nothing to eat. Okay. So these are links related to linking biodiversity and ecosystem function. There's a lot more in the book on this that's worth looking at, I think, if somebody happens to ask a quiz question on it, for example. What controls lengths of food chains? This is sort of related to the ecosystem production that we just talked about. And if there is energy limitation, right, and we'll talk about this again in the ecosystems, but if there's a limitation on the amount of energy that makes it up through the food chain, if there's only 10% makes it the first time, and 10% of that, so you're at 100th of the energy, right? And a 1,000th of the energy. So there's, at some point, there's not going to be enough energy to support the length of the food chain. And that's, you know, really dependent upon where you are. Some systems, some people argue that production will limit the length of food chains, and others don't. So, you know, the hypereutrophic examples is one such that there's a lot of production, but the food chains are probably pretty short because you're not going to have many fishes and big predatory fishes in them. They can't deal with the anoxia. But if you have a super oligotrophic system, like a groundwater or the lake that we were just speaking about, where the fish can't even barely make it, there's not snails, maybe that would be a limitation on the length of the food chain. Marine food chains are quite long, and organisms are very evolved there to take advantage of every little step. So that's probably more important in marine than in freshwater.